Hello and welcome to 9.2 Arithmetic Sequences. So an arithmetic sequence is a sequence in which the difference between two consecutive terms is constant. This is called the common difference. So arithmetic and common difference. Oh, wow. I apologize for my handwriting on the touchscreen. That is very bad. That's a little better. Okay. All right, so it's called the common difference. So basically, an arithmetic sequence is going to be one where our first term is going to be some number a, and then the second term would be a plus a number d, and then the third term, we're going to add d again, so that's a plus 2d, and then we're adding a d again, so that's a plus 3d, and so on. The recursive formula is going to have the first term is whatever a is, right? That original number. And then the formula, the recursive formula, they use a n plus 1 equals a n plus d, which is exactly the same thing, just stated in a different way as what we've been using, which is a n equals a n minus 1 plus d. So basically what this is saying is that the next term equals the current term plus d, and this is saying the current term equals the previous term plus d. So it's saying the same thing, just in a different way. And I prefer this notation better because then we're always looking for the current term, which is the same format we use with the explicit formula. So to keep it consistent, I like to do it this way. And then just saying that n is always going to be greater than or equal to 1. So we're always starting with the first term, and then the second term, and then the third term, which should hopefully be obvious, but we state it anyway. All right. So that's the recursive formula. The term equals the previous term plus d. The explicit formula is going to be that the next term equals a plus n minus 1, so the term number that we're looking for, minus 1 times d. So notice if a is 1, then I have 1 minus 1, so that's 0 plus d, so I just get a, which makes sense. I want my a1 to just be a, so that's why it's n minus 1. So, and then if I'm looking for term 2, then that's a plus 2 minus 1 is 1d. So the second term is just a plus 1d or a plus d. The third term would be a plus 2d and so on. So this n minus 1 gives us the number that we want in front of our d for each term. Okay, so let's do an example of that. If a is 2 and d is 4, we're going to write the first 4 terms of our sequence. So the first term is just a, so that's 2. The second term is going to be a plus d, so that's 2 plus 4 is 6. And then we can either think of this as adding 4 each time, or using our explicit formula, it would be 2 plus 2 times 4, 2 plus 8, which is 10. And so then the next term is going to be 14, and so on. So we get 2, 6, 10, 14. If we wanted to write out our explicit formula, that would be an equals 2 plus n minus 1 times 4. So we can actually simplify this, right? We can distribute the 4. So we get 2 plus 4n minus 4, which is 4n minus 2. So this is the simplified version. This is exactly the same thing. So we could use this formula to find our terms, right? If I wanted, say, the 10th term, I could just say, okay, so that would be 4 times 10 minus 2, or 40 minus 2, which would be 38. So my 10th term would be 38. Okay. So I'm going to be doing some examples with this in the next video.